Hello, my name is Rutger Myers, and I'm the Director of Compost and Carbon Farming at EcoCycle. Um, my goal for today's lesson is to teach you concepts. I'm not going to be able to give you a list of how to make your perfect compost pile because every compost pile is going to be different. My goal is to give you guardrails for you to work within and give you the skill sets to make your own decisions on the spot for your compost pile. Um, A little bit about me. I started as a farmer in right before 2020. I farmed for 3 years as a seasonal farmer, and I just absolutely fell in love with the work. As you can see from these pictures, farming is a lot of fun, and I will always cherish that experience. But in order to get into agriculture, I had to make myself useful on the farm, and that was through compost. Um, all my peers had years and years of experience in growing. I had none, but my farm was not composting. And there's great value in building a compost program, which is what I did over the next 3, 4 years. So in building the skill sets to becoming a composter, I attended the Denver Denver Community Composter Program with Denver Urban Gardens. I encourage you to find a community compost program in your town, or if it's not there, maybe start it, because community compost is the heart and soul of composting. We need to support more small scale composters so that they can build a relationship with the large composters. That's how I got into composting, and that's how I've seen many others get into composting, which is through small scale and then building into agriculture and then getting into municipal. Another great resource, the Soil Food Web. I highly recommend that you look up Dr. Elaine Ingham, and it's the soilfoodweb.com. What she teaches is soil ecology. What she teaches is soil, by definition, is alive. If there's no life in soil, it's dirt. There's a big difference. Um, and all the nutrients, all the chemistry that you hear about soil, that is dictated by biology. And we need to understand biology better. So through the eyes of a composter, especially, soil ecology is enormously important. I encourage you to start small. This is how I started my compost program at Chatfield Farms. I started with a single backyard style pile. I learned the concepts, I learned how to manage my piles, and then I incrementally built over the years. This is me building a pile by hand that I could no longer turn by hand. So this was that turning point of scaling up, which I implore you to do. Always think about scale when you're making your compost pile. Being a composter is a unique experience. Um, the first rule of composting is you have to talk about composting. I mean, once you learn how to compost, especially in a community, you start educating, and it's a real part of the job, and it's a pleasure. I mean, I love doing this tonight. I love teaching kids, which is a great part of my job. But then I also get to drive tractors and skid steers and front loaders and look at my compost under a microscope. So, composters are jacks of all trades, and it's a requirement for the job. So if you're interested, we need more composters. So if you take something that you like from this session, take it and run, and there's a tremendous opportunity for composters right now. So now I work for EcoCycle. EcoCycle is this wonderful recycling mission-based nonprofit, also started in 1976 with school buses picking up recycling from front yards. I mean, can't get much scrappier than that, and I love working here. But work as a recycler, things are a little different from a composter. Um, when you're recycling, you're taking natural resources and you're distributing them. You usually get them in a single stream, your recycling bin, and you need to find markets for all that material. You're kind of like a dealer. You're finding vendors, you're finding avenues for distribution. Composting is, yeah, it's still about conserving natural resources, but it's a creative endeavor. When you're making compost, you're building a recipe. Food scraps on its own is just rotten garbage, right? But if we put food scraps with wood chips and manure and fall leaves and we mix it up and we treat it right, we create a product that we have a hard time quantifying just how beneficial it is for our planet. Everything is based off of the emissions reduction from keeping organics out of the landfill. That's extremely important. But I would argue that the value of compost, the true value of compost, comes from applying it on our soils, sequestering carbon, allowing our soil to breathe, allowing our earth to breathe. Soil is like the earth's lungs, and we need to sequester carbon and we need to cycle carbon better than we are right now. So I still get to scratch that itch of working on farms now. I work with 8 farms in Boulder County, and we're kind of doing both. We're connecting food scraps to agriculture. We're teaching farmers how to compost. And what separates our program is we take tremendous efforts to make high quality compost. The basis of compost cannot be framed around waste. It cannot be a diversion conversation alone. We have to build recipes, and the goal of the project has to be building soil. And that's what I'm asking you to do today is focus your compost around building soil, not around reducing waste. That's just a happy byproduct. So now I want to pause and I'm going to take poll 1. I want to get a better understanding of where everyone is at in this audience. Are you composting in an apartment with a worm bin? Are you composting in a backyard, a community garden, or are you working with machines at a larger scale? If you have your own composting business, that would be an on-farm category. I'm just trying to figure out the scale that everyone's working so I can kind of talk to everyone's situation.
Gonna leave the poll up for just a little bit longer. We've got a few more folks waiting to answer. All right, sharing those results now. Rutger, can you see those?
Yep.
Beautiful.
All right. I see pretty much, almost 90% of you are working backyards, and I really like that. That's where there's a lot of potential. I see maybe 1 or 2 of you are on farms, community gardens. And then I appreciate there are a lot of people from apartments here because that's tough composting. I would recommend worm bins for you, and because you can do that in an apartment. I do that in mine. Okay, let me get my. Okay, so now I want to talk about what is compost. Um, I would call it a microbial inoculant. It's pretty nerdy. But what I want you to understand is compost is not a fertilizer. Compost is not about the nutrients, it's about the microbes. The microbes are what cycle nutrients. So when I measure the health of a compost pile, I'm just looking at microbes. The nutrients come with the microbes. So when I'm saying a microbial inoculant, what I mean is compost is like the kombucha starter for your soil. You're taking a culture of bacteria and fungi that would naturally want to live in the soil. It's the culture of microbes that make your soil healthy, and then you're applying that to your soil in a high concentration. So I want you to think of fermenting. I want you to think of when you inoculate something with healthy microbes. And what do I mean by healthy microbes? I mean aerobic. I mean the microbes that breathe in oxygen like us and breathe out carbon dioxide. There's a whole nother set of microbes that are anaerobic. They don't like oxygen. And these are the microbes that we need to watch out for. These are the microbes that will make us sick. So as long as we're aerating our pile, which I'll talk about later how to do so, that's how we keep our compost healthy. We want the conditions that promote the life that we live, which is an aerobic life, right? So where do I start? This is my first compost pile. I ended up producing 300 tons a year, and this is how it started. And it took only 3 years to make my program happen. Um, 3 by 3 by 3 is about your minimum. So about a cubic yard. Um, when you make your first compost pile, think about the effort that it takes to make that pile because you're going to want to turn that pile once a week. So don't make a pile, don't bite off more than you can chew. Make a pile that's manageable. Super important. Um, this is your first step by step. The first thing you want to do when you're making a compost pile, you want to stockpile your browns, especially in a backyard. You're going to run out of browns by the end of the year. You don't have enough wood mulch or straw laying around to match all the greens that you're buying. And if you're composting food scraps, you need a lot of browns to match that. So at home, depending on how big your site is or to how big your ambition is, you might want to order a chip drop. Those are what, 5 to 8 cubic yards of chips. That's quite a bit. So you'd have to have a pretty big property to do that. Um, if you can't, you need to start collecting leaves in the fall. A lot of neighbors will have leaf bags out in front of their houses, and that's a great opportunity. You can store those leaf bags, but my point is you need to have your browns, which usually come in the fall, to match your greens, which usually come in the spring. So it's a year-long process, and the browns are probably the most important thing. Your browns are at least 2/3 by volume. You want to have 2/3 browns to 1/3 green. And that's not a ratio that's set in stone, but it's a good starting point. Um, then you add your greens. Um, you want to chop everything up as well as you can. Throughout this presentation, you're going to run into limitations. You're going to say, well, I can't do that. That's fine. You don't have to do everything I'm saying, but you want to shoot for about 1 to 2 inch particle size, and you can chop it up any way you want. At a community garden, we had shovels, and we used to um, shovel chop in a circle, and that was super effective. Um, you also want to mix your pile up very well, and you want to water as you mix. Um, Here in Colorado, your pile is almost certainly going to be too dry. So watering it, especially at the beginning, is super, super helpful. If you want to get really, really fancy, you can soak your wood chips overnight. That brings a tremendous amount of moisture. But I want you to always be thinking of how can I water my pile? How can I get my pile wet on the inside? How can I wet the core of the pile, not just the outside? So that's why I'm recommending as you mix, as you assemble, water in layers. Don't just water the top because it won't make its way through to the middle of the pile. A good way to think about this is tracking how we treat our bodies. The compost pile is a living, breathing organism. So you want to treat it as you would treat any other organism. You want to feed it healthy foods. You want to exercise by turning. You want to chew at your food. And of course, all life needs water. So these are kind of the essential points in assembling a pile. Okay, greens and browns. I'm sure you've heard many, many times you got your greens and your browns. I've said it already. But what do I mean when I say a green? What do I mean when I say a brown? Greens are your vegetative waste, like your food scraps, your weeds. They tend to be wet. So a good way to think about it is like, how recently was this plant alive? Um, if it's super dried out and it's a wood chip or a fall leaf, that's going to be a brown. You can pretty easily track this by color, like most of the greens are greens, most of the browns are browns, but there are a couple exceptions. Coffee grounds, for example, those are greens. Manure, that's a green. In fact, I count those as double greens because they're so packed full of nitrogen that they supercharge the pile twice as much as your normal green would. Um, I just said nitrogen. So your greens are your nitrogen heavy material, and your browns are your carbon heavy material. But I keep talking about this recipe, but the most important thing is we want to think about who is eating. who are we building this meal for? Well, your browns are your fungal foods, and your greens are your bacterial foods. And just by nature, these creatures operate differently. Your bacteria is what brings the heat. Bacteria are super, super, super small. I look at them under the microscope with a 400 times magnification, and I can still barely see them. So the bacteria, they're always moving around. They're always darting around. Um, and they reproduce every 20 minutes. So they're expanding, expanding, multiplying, multiplying. Fungi is a whole different kind of animal. Um, Literally, they're closer to us genetically than they are to plants. Fungi grow out in a web. They produce mycelium, which is that web that kind of grows out in the soil. And every 3 hours they reproduce. So they're much slower moving. They like cooler temperatures. Bacteria, they're all different sets of bacteria. They're the thermophilic that like the high temperatures. They're the ones that like the cooler temperatures. Fungi, they kind of like temperatures closer to us. So the fungi, which is an extremely important part of your compost pile, aren't going to take over until the curing process. So the turning and the heat and the steam and all the things you're thinking about, that's all the bacterial phase. Um, I want to encourage you to focus on that fungal phase, which is easy and hard at the same time. It's easy because all you got to do is let your pile sit. It's hard because how long am I willing to let my pile sit? If I had a pile that could sit for 3 years, it'd be the healthiest pile that I've made. But I have not had I've not had been strong enough to not spread my compost over 3 years. So the longer you let your pile cure at the end, and the more fungal food there is in that pile, the healthier it's going to be. So a variety in diet, as I mentioned, um, tracking human health and the health of a compost pile, we want to treat it like we would our bodies. So if I only ate kale, a little bit of kale is really good for me. It's a really great food, but if I only ate kale, I would probably not get everything that my body needs. I need variety. I need fiber, right? I need other things in my diet. So that's why I encourage you to try to get as many different feedstocks. That's what we call the material that we put in our compost. It's feedstocks. Um, and you want to make a very diverse diet for your compost pile. And with this kind of recipe, this is where you can kind of tinker. I'm going to just touch on it a little bit, but you can make different composts for different plants. Not all plants want the same kind of compost. And um, the logical way to think about it is think about what the plant is and what would be naturally breaking down around that plant. So if I were to make compost for grass, I wouldn't incorporate a whole lot of wood in that material because grass comes from grassland. There aren't a lot of trees in grassland. If I were to make compost for trees, I probably wouldn't put a whole lot of grass in that because what breaks down around trees is wood, more trees. So a compost for trees would be more fungal, more wood heavy, and a compost for grass would be more bacterial, more nitrogen heavy, more grass heavy. You want to match the biology that already lives in your soil. So I want you to understand what your purpose of your compost is, and I want you to understand that there's no recipe that's set in stone to make an all-purpose compost. Um, you're probably growing vegetables. That's what most people make compost for. And for vegetables, it's right in the middle. It's about half fungi, half bacteria. Um, that's, as I mentioned before, that fungal phase is harder than you think. So you'll almost certainly have a bacterial compost. And if you want to make it balanced half and half bacterial fungal, you want to let it sit for a little bit. I want you to learn how to manage intuitively. So this is an example of a pile I built. So you can see there are multiple greens. One category is mixed greens. I would just get all the vegetables from the farm, all the botanic gardens things, all put into one bay, and it was all kinds of things. It was an incredible variety of material. Um, Mixed browns, same thing. So I couldn't even track all the different plants that I was putting into my compost. Um, and then again, just a little bit of manure. If I made my manure, my compost pile half manure, half wood chips, it'd burn up. It'd get really hot because manure, as I mentioned, is like a double green. It's a super nitrogen. It'll heat your pile up really quickly. I want you to look at the bottom one, ratio by volume. There's a little blue slice in there. That is my inoculant. Um, I mentioned inoculant for soil, but you can also inoculate your compost pile. And I would do this by taking scoops of my last successful pile and putting it into my next pile. Um, I would do it, as you can see here, it's about 3-4% by volume. Didn't get that scientific about it. I'd put about 1 cubic yard in my 50 cubic yard pile, whatever. And it really sped things up. Another tip, if you're tracking the concept here, take a handful of soil, not a lot, just a handful of native soil. Sprinkle it on top of your compost. What does that do? As I mentioned, soil by definition is alive. A handful of healthy soil has more microbes in it than there are humans on Earth. So it's incredibly vast. It's unfathomable to understand. But just take a handful and put those 8 billion microbes on your pile because they're the ones that already live in your soil. And if they're the ones that are in your compost pile driving that decomposition, they're more likely to survive in your soil. They're the native microbes. Okay, so I'm going to take another quick poll. Um, what is your recipe? Are you working with kitchen scraps, weeds, manure, wood chips? Um, what I meant to do was I meant to have a multiple, you could select multiple here, which was totally my mistake. But why don't you go ahead and pick from the greens, kitchen scraps, weeds, or manure? If you're using manure, I understand you probably have some weeds around too. Um,
Gonna leave it up for maybe another 20 seconds or so. We've got about a 66% responding rate right now. Okay, got about 70% of folks have answered already, so we're going to end this poll and share those results.
All right, great. And I apologize for I meant to have you could check multiple boxes, but I never told that to anybody. But what we see here is you're mostly using kitchen scraps. Kitchen scraps are kind of a wild card. It's a lot of nitrogen packed into a small box. So composting with kitchen scraps, good to know that's what everyone's working with. Weeds, crop residue, a lot more forgiving, a lot easier to work with, a lot more channels for oxygen to flow through. Food scraps tend to mat together, tend to clump together, so you want to put extra time into mixing those evenly throughout your pile. Okay. Okay. So if you are building a pile or building a compost system, the first thing you want to do is make sure you organize yourself. Even if it's just you, get yourself organized. You want to store your browns, as I mentioned, but you probably don't want to store your greens. Um, this was my brown stockpile as I was building my site. I tried to keep the green bin as empty as I possibly could. So I would empty that green bin at least twice a week and incorporate it, match it accordingly, about 60% browns to the 40% greens and mix that up. In a larger pile, it was more like 75% browns, 25% greens. Um, so when you have your greens and you're not ready to put your pile, suppose you only have like a banana peel. What do you do with that? Do you just throw it in your pile? You could do that, but you would have to match the certain amount of carbon to that nitrogen. You want to have that 60-40 ratio, right? Um, so a couple pointers to storing your greens. At home, I have a 5-gallon bucket with a super tight lid and I seal it. Um, at my apartment, which is kind of like a science experiment, I put Bokashi bran, which is kind of like a pickling microbe in that, which kind of pre-breaks things down. Um, More normal ways of storing your food scraps, you might freeze them. If you have room in your freezer, freeze your food scraps until you have a critical mass to match your brown material. Um, if you have a lot of space and you're working with weeds or plant residue, lay them out and dry them. If you're not ready to put in your pile yet, you can dry that material out. And the point of all these measures is to keep your green pile from going anaerobic. Because if there are no browns to match, if there's not enough oxygen flow, um, all those microbes are going to take over and breathe in all the oxygen. So you don't want to have a stinky pile of greens laying around. That's not a good thing. If you are building a shared system at a community garden, which if you have a community garden, you should try to get everyone composting, but you need to stop the influx to the mystery pile. This was my first step in starting the compost. There was just a free-for-all pile. Everyone's just throwing everything in one pile. I have no idea what the ratio is. I have no idea what the recipe is. So you need to stop the flow. And if you're working with multiple people, either be super good at communicating who's putting things in the pile when, or designate one person. When I used to teach community gardeners, I would recommend make someone the compost captain. So everything goes through them. They have to manage the pile. And again, it's all about building that recipe intentionally. That's what all this is. Chop it up. These are things we mentioned before, and these are different ways that I used to chop things up. Um, One, I had a lawnmower. Um, I used this to varying success. The thing I did not like about the lawnmower is it tends to pulverize. I said 1 to 2 inches. If it's, if everything's just pulverized, there's not enough pore space for oxygen to flow. So you want to make sure you chop things up, but you don't want to make a smoothie. Um, this other one where I'm hacking away at root balls. The point of this is I probably wouldn't put root balls in my compost. I spent plenty of time hacking root balls by hand, and then I went to A1 Compost, one of the largest composters in the country, and they're saying, we don't take root balls. And I'm like, oh, maybe I shouldn't either. So just be careful. Don't hurt yourself trying to chop things up or do something silly. Work within reason. This is another method with varying success, but this is how you could do it on a larger scale. This is a flail mower on a tractor. It has like a bunch of knives that spin up and down, and it was pretty effective. It would pulverize some stuff, leave some stuff intact. If you're that one on-farm composter, I wouldn't recommend doing this with your flail mower. It's pretty tough on the equipment. But the point in this slide is there are just many, many ways that you can chop up your material. But it's pretty important. You want to make sure you're chopping up your material because if it's coming in big clumps, it's not going to break down evenly. Okay, mixing. Mixing is critical. This is especially if you're working with like a static pile that you're not turning regularly, you need to get the mixture right. And this is a perfect mixture. I mean, we have a whole group working from 360 degrees. We're all shoveling. The only thing we're not doing here is we're not watering, but in this case, we've loaded all this in a wheelbarrow and we assembled the pile elsewhere. So we held off on watering until we assembled the pile. We got the mixture right. And then when we assembled the pile, we had one person watering and another person loading that pile. Well, this is another one. Oh, here we go. So this is if you're alone and you're mixing, set all your stuff in a circle. Notice in this one, I have a sprinkler running. I'm wearing muck boots. I'm wearing my bathing suit. So I'm getting really wet here, but the pile's also getting pretty wet. And I'm watering as I'm mixing the pile. Um, this was when I had machinery. So after the pile was wet and mixed, I could then at least shuffle the material up. At the time, I had forklifts or had forklift attachments on a skid steer, so I couldn't fully scoop, but I could at least shuffle it up to turn. So we're talking about watering. How wet should I get my pile? How wet is too wet? Um, you can get a moisture probe, but the thing about a moisture probe or a temperature probe, they only measure the very tip of the probe. So you'll get wildly different measurements depending on the depth. Maybe it's a wet spot. Maybe you penetrated an orange, so you get like 100% moisture. Your hand can get a much more holistic approach assessment. Um, take a handful and squeeze it. If it forms a ball, it's almost there. If it's feeling like a wrung out sponge, that's good. If there's just a couple drops, that's perfect. That's where you're at. That's where you're at 50 to 60% moisture. Um, if you squeeze it and a bunch of water runs out, that's too wet. Um, so you want to find the balance between um, squeezing it, nothing comes out, super dry, powdery, and it's just totally waterlogged and soaked. You want to find a wrung out sponge texture. Um, On to watering. Watering, it depends on if you have a machine. So this was a machine-based system. I would water my piles and then turn. So I'd water first and then turn. Um, doesn't matter to me if the machine's putting in a little extra work to carry that water. If I'm working by hand, there's no way I would water my pile this way. By hand, you want to water as you're assembling the pile. So do your scoop, water, do your scoop, water. Don't carry more weight than you need to because turning a compost pile, um, it's a challenge. It's a physical thing. Um, as the pile gets older, the material gets more spongy. Compost is really good at absorbing and retaining water. That's one of those benefits that I'm talking about in soil is we can reduce watering by over 30%. Compost is super spongy. So in the later part of your compost, when it starts to look this dark, rich, composty material, it's going to be super absorbent and you're going to have to water it way less. So keep that in mind. Um, Even in a tractor-based system, watering is super important. I'm the director of the department, and I will make house calls to our farms just to hold a hose and water as they turn. Watering as you turn is the best way to do it. So if you can water every single scoop, every single dump, because you want to get moisture in the center of the pile. If I were to turn a pile and then go water the outside, you're not really doing that much because a lot of that water is going to evaporate. A lot of that water is going to run off the sides of the pile, and none of it's going to get to that center core. Okay, so why is compost so hot? Um, well, I love compost in the first place, but physically, what makes a compost pile hot? Um, it's the microbes. So I mentioned the bacteria. I mentioned they reproduce every 20 minutes. Um, it's their body heat that's actually heating the pile up. So imagine 300 people in a room and everyone's running around. First, it would get really hot, and then it would get really stuffy. And that's what's happening in the middle of a pile. It gets really hot because all these microbes are getting hot and heavy. I mean, they're reproducing. That's what's making the compost get hot. Um, and they're also getting stuffy because they're breathing in all the oxygen. And that's why we turn a compost pile. Oh, next slide. That's why we turn a compost pile because we run out of oxygen. The bacterial phase happens really fast. They reproduce really fast. They break things down really fast. You'll get super excited because your pile will decrease by volume by like a third in the first couple weeks. This was a week. Um, so you'll get really excited, but breaking down the material is not the full story of compost. So it's really good that that's happening, but it's just the first step of the process. And yeah, it's super exciting. So I had skipped ahead a little bit, but this is why we turn compost. It's to aerate the core. So when that party's happening in the middle of the pile and all the microbes breathe up all the oxygen, there's no air, and that's when that disease-causing anaerobic bacteria come in and take over. Well, you turn the pile. You get all that disease-causing bacteria exposed to oxygen and they die off. So that's the function of turning a pile. There are also many other reasons you want to turn a pile. You want to evenly distribute water. As I mentioned, I used to saturate the outside, mix the water in evenly, and then you're sort of evening the playing field. Especially in earlier stages, you will have clumps of browns and clumps of greens, and you don't want that. You want everything mixed up. So you don't want hot spots, you don't want cold spots. Composting balances everything out. It makes an even playing field for bacteria and fungi and reduces those patches where maybe a bunch of bacteria will flock up and breathe in all the oxygen. We want to reduce those anaerobic spots in your compost pile. And why is oxygen so important? Um, it's the same concept of a red tide. I'm from Tampa, Florida, and a couple years ago, there was a red tide in our bay. And what happens in a red tide is there's a bacterial food, in this case, a fertilizer, phosphorus leached into the bay from a fertilizer plant. And then there's this influx of bacteria. And the bacteria breathe up all the oxygen in the water. And it kills fish, it kills plant life. Um, it becomes like a plume of bacteria. And that is not good for your soil. That's what's happening in the center of your compost pile. You're creating a red tide. And just a little bit of a side note, this is how agriculture can become a greenhouse gas emissions factor. Because if you're not managing these piles and if you're mismanaging soil and there's too much bacteria and not enough fungi, there's so much that they breathe out enough carbon dioxide where it becomes a problem for our planet. The opposite, if you balance it with fungi, that's where you sink carbon. The bodies of the microbes, especially fungi, are made out of carbon like us. And that's how we balance soil. That's how we sequester carbon. It's through biology and the byproducts, which I'll get into later when we talk about soil. So when we look at this pile, we say, okay, where's the heat? I'm looking at the pile and it's steaming all over. It looks like it's hot all over. This is a basic distribution of temperature of your pile. You have a hot core. It's kind of like the oven. That's where the magic happens, right in the middle of the pile. This is the part that will get anaerobic. This is the part where there's so much bacteria breathing up the oxygen. So when we turn a pile, we want to be intentional. We want to make sure that that outer part of the pile, which is not really composting because it's so exposed to air and it's probably not wet enough, it's probably not compacted enough. You want to get the outside of that pile into the center of your next pile when you turn. So we're managing the oxygen levels of the pile. Then you want to get the center core and you want to distribute that out to the outer layer of your pile. You want to oxygenate that part that may be anaerobic. This is an example. This is my little science pile on the farm. I really love the cylinder systems because you get more even watering. And I'll be honest, this was a pain in the butt to do this, to separate the core from the top and the bottom and then put it all back in an intentional way. But it was worth it. I mean, this was a pile that I was looking at under a microscope with a mentor, and we were talking back and forth, and we were managing these little changes, and we were tracking the biology. So it did make a difference, even though it was small scale. Um, you can actually track how much bacteria is reproducing based off of temperature. Your temperature probe is probably your most important tool, either your temperature probe or your manure fork. Those are the tools you need. Um, I know that for every 1 degree my pile heats, there are 100 million bacterial reproductions. So the project here was I had a trail camera taking a picture every hour, and I had four temperature probes measuring the outside, the center core, and then the other side of the pile. And I would average those temperatures out. I would take a picture every hour, and I would get an idea of how many bacteria reproduced in that pile per hour. Super nerdy, not necessarily something you want to do at home, but this is how you make the highest quality. And I want you to understand this concept when you're using your thermometer. And the same concept can be applied to larger scale. This is, as I scaled up, I tried to keep the same concept. I'm not taking the center core and putting it right in the middle, but I'm intentionally turning away in a way where everything will eventually make its way to the center. So I would build out of a line and I would take from the sides and try to get that in the middle as much as possible. Okay, so this is your turning schedule. This is the ideal turning schedule. Um, 131 degrees Fahrenheit is sort of a magic number. It's a magic number because that heat, 131 degrees Fahrenheit, kills about 90% of the bad guy bacteria in your compost pile. Um, it doesn't kill all of them because you don't want to sterilize your pile. We don't want our pile to get, 300 degrees because then we would kill our good guys too. So if your pile is 130 degrees, wait 3 days, turn it. If it's 140 degrees, wait 2 days, turn it. If it's 160 degrees, you want to turn that pile because once you get to about 160 degrees, that's when you're damaging, yeah, you're killing probably over 90% of the bad guys, but you're also damaging that good guy population. That level of heat is not necessarily good for the aerobic bacteria. So when your pile is 160 degrees, I know it's something to be proud of, especially in small scale. People are like, how hot is my pile? You don't want to leave it that hot for too long. You want to keep it around 130, 140 degrees. That's your optimal temperature. So this is an example of a turning to temperature log. And I would keep this for every pile. Um, so your temperature will increase. When you turn, it plummets, and then it'll slowly build its way back up. A good measure of the health of a pile is how quickly does it bounce back up. That's a measure of health. And if it bounces back up and stays at 130, that's wonderful. If it bounces back up and gets to 165, maybe you might want to think about adding some browns to cool that pile down. But this is the general flow of temperature over a life. It kind of arcs. It heats up, and then it slowly cools down. Um, and then this is oxygen. Your oxygen levels, as you turn your pile, the oxygen spikes. And then as the pile sits, that level slowly decreases. And you can tell this based off temperature. Again, how hot that middle pile, that center of the pile is an indicator of how much oxygen is in the middle of the pile. So you put the two together and you can see that they're inverse. So as the temperature goes up, um, the oxygen level goes down. So this is a very important concept I want you to understand. Um, Bigger piles are more forgiving. You'll see fewer spikes. You'll see higher heats. But if you get a recipe that works and keeps it kind of below 150, you won't see those spikes as much. But you will want to turn that pile more frequently. So what happens if I don't turn my compost? Spontaneous combustion. I don't want you to worry about this at home. It's not going to happen in your backyard pile. Um, but if you have a pile that's big enough, in extreme cases, it can catch fire on its own. So how does that happen? Does my pile get 400 degrees where it will burst into flames? No, no, it'll get to about 180 degrees. And what happens is The same thing that happens if I were to put a bunch of grapes in a Ziploc bag and seal it. What happens? I'll make prison wine that way, right? If I seal up grapes, it turns into wine. And that's what's happening in the middle of your pile. There's a bunch of sugar and a bunch of bacteria that eats that, and when it eats it, it produces alcohol. So if there's alcohol in the middle of your pile and it's 180 degrees, all it takes is a spark, and that's how spontaneous combustion can happen. If you do not have access to, or if you don't have the willpower, or for whatever reason you don't want to turn your pile, there's a quick fix. You can add chimneys. This is from on the farm. My skid steer was down for 2 months at one point, and I had a quick fix, which was I found a giant nail on the farm, and I would just poke holes. And hey, guess what? No fires. But it's good for the pile. It promotes oxygen flow. It's not the same as turning, but if you add enough holes, you can aerate that center core. You can add, it's kind of like a Band-Aid, a quick fix for that no turning problem. Um, what if I don't have a thermometer? How do I know when to turn my pile? If it smells bad, turn it. A bad smell in your compost is your pile losing nutrients in the form of gas. A bad smell of compost is an indicator of anaerobic bacteria. They produce gas that stinks to us. It stinks to us because it makes us sick. It's our DNA telling us, don't eat that. So as a composter, you're kind of like a sommelier. A sommelier is someone who can smell and taste wine and can tell all these factors about wine based off of the texture and the smell. And how are they doing this? Um, there's a movie called Somm that like tracks sommeliers through their master training and their testing. And I thought it was just hilarious, and they were totally full of it. But then when I became a composter, I understood the concepts. What they're doing is they're smelling the gases of a microbe that ferments that's local to a small town in France. And they say, okay, that smells like bubble gum. And they say, well, that microbe in France produces a gas that for whatever reason smells like bubble gum. It's that kind of thing. It's that ridiculous. As a composter, it's super easy. If it smells bad, turn it. If it smells bad, don't eat it. And I implore you, if your compost smells bad, don't put it on your plants because it's not going to be good for your plant and it's not going to be good for you. So it's easy. I mean, it's part of us as humans. We have the indicator of our sense of smell. So using that is very important in composting. And there are many, many smells that will come out of a compost pile. A mismanaged compost pile might smell like rotten eggs. It's actually not that there's eggs in that pile. It's that the microbes that like to break down eggs are taking over your pile. Your pile could smell like vinegar. It could smell like urine, like ammonia. No one's peeing on that pile. It's just the ammonia being produced by the microbes. And it can get pretty wild. I mean, you can smell vomit, which is valeric acid. You can smell decaying flesh, which is putrescine. And it's not, I mean, it's incredible. It's just the gases that are familiar to us and that thing, and that's what's producing that smell. And it's pretty easy because it's a bad thing. You want to turn the pile or add carbon, but it's interesting to understand that those things happen. The smell you'll smell the most is methane. Methane stinks. I think you know what it smells like, but if you don't, even if you're doing well, you'll smell methane sometimes. That's 84 times worse than carbon dioxide for our environment. It's important that our compost piles are not producing methane as they would in the landfill, right? Okay, I want to take a quick pause and take a couple questions.
All right. We've got a bunch of different questions, some a little more specific, some more general. And we're going to be focusing on the more general ones, try to reach as many people as we can. So first thing, I'm seeing a lot of questions. You'd mentioned that magic 3 by 3 by 3 ratio. That's like the ideal starting point for starting a compost pile. Some folks have mentioned that they have compost bins or tumblers that are a little smaller than that. And I'm wondering, does that still work? Is there a good reason why we wouldn't be using those?
The tumblers are tricky. It's hard to get enough oxygen flowing through those to make an aerobic product. Um, I don't want to make you destroy something you bought at the store, but I usually recommend drilling a lot of holes in that. Um, if everything's compacted in there, not like pressed down, but if it's filling the space nicely, I think you could get away with an enclosed pile a little under that 3 by 3. But I think I hate to say it, overall, those tumblers and those sealed methods, you got to find a way to put more air into that, whether it's spinning it more or drilling more holes in it.
Great. Thank you, Rutger.
Yeah.
Next, we've got a few questions asking about like what materials we're putting into our compost pile. First is if there's certain manures that are better than others.
There are, and it gets pretty complicated. Goat manure is less broken down. Horse manure, I worry about contaminants. Um, Pig and cow manure, I worry about metals a little bit. So every manure has its like drawbacks and its pros and cons. I would just be careful about the source of your manure. That's the most important thing. Make sure there's no antibiotics or dewormers, especially being fed to that animal.
In that same vein, are there like specific plants or weeds that you avoid when making a compost pile?
Yeah, that's a great question. It always comes back to size and scale. In your smaller piles at home, I would try to get your weeds before they go to seed, weed seeds. Yeah, if it all ends up in the center and you do it perfectly, you'll kill all those weed seeds. But in a smaller pile, it would be a little bit of a concern to me. I would implore you to steer away from, maybe think about steering away from bindweed. That reproduces through the root. I never had a problem in a bigger pile. But then also the same goes for like disease-prone plants like tomatoes, cucurbits. They tend to pick up diseases more often. So you got to be totally sure you're putting a healthy plant in that compost pile. If you know it's diseased, maybe avoid.
We were talking about browns, different additives we can use. What about cardboard boxes?
Um, that's tricky. I mean, if you can recycle it, I would use that first. Especially on food products. These days, I'm getting more concerned about contaminants in the paper fibers. I don't want to scare anyone away, but I'm personally no longer using cardboard in my piles.
Great. Maybe just a couple more. I don't want to take up too much time in your presentation. Um, Someone asked that if they have a bad smell, like what we just talked about, does that mean that the pile's done for? Can it still be salvaged?
Yeah, you can always salvage a pile. Like you can take some pretty rotten stuff and make great compost with it. Aerating it is really the key. Adding carbon also helps. Like if your pile's wet and mucky and stinky, add some leaves, add some wood chips. I didn't mention the wood chips are really about the pore space. So they're really like an oxygenator. They add air pockets and allow your pile to build up and have some structure to it. So usually if it's stinky, I'd put wood chips in it.
Great. Last question I'll ask you for the time being. Um, we had someone asking, if compost has a lot of microbes and they're constantly reproducing, why, continually add compost to your garden? Why, I guess, why does it not kind of stay in that steady state with microbes continually reproducing?
Yeah, I mean that's a deep question.
Yeah, and if we don't
Your
have time,
soil, yeah, your soil can get, I mean, it can be healthy enough to where it won't need compost. Like natural areas in a healthy ecosystem does not need compost. When we're growing vegetables in particular, we're kind of growing something that wouldn't necessarily grow there naturally. So that's why we're amending our soil. You can make a veggie farm produce soil that will naturally cycle nutrients and you can get to that point where you no longer need compost, but you got to be really good at farming.
okay, thank you so much.
Mhm.
For those of you whose questions we didn't get to, I do apologize. You can see Rutger's email shared here at the bottom of the screen. We'll have it up again toward the end. And hopefully we'll have a little bit of time left over at the end for some additional questions.
Great. All right, I'm gonna try to pick up the pace here. I have a lot to share. We were talking about gases. I'm picking up the pace, but I'm also taking a little side story. Some of these gases you can't smell, and this is just a side note that I love to talk about. The idea of ghosts may have come from microbes. There's a microbe that produces a phosphine gas when it eats flesh, and it produces this gas that's you can't really see it in the light, but in the moon at night it kind of shimmers and it kind of like wades back and forth. Um, so I always like to mention that ghosts may have come from microbes. That's where that idea may have come from. So it's an ancient connection, us and microbes. Okay, now we're going to talk about um, your sense of sight, things that you can see, observations about your pile. This powdery stuff in the middle of your pile is actinobacteria. It's not necessarily a bad thing, but it means oxygen levels are going down. This is a bacteria that likes low oxygen levels. So it's not anaerobic yet, but it's getting there. So if you see this kind of off-white, kind of looks like ash, time to turn your pile. I want you to be able to tell the difference between actinobacteria and fungi. Fungi is whiter and stringier, and it eats wood. So you'll see, if you see this, especially in the curing phase, it's doing great. That's the fungal stage kicking in. And it kind of grows in strips. Like you won't see it at the center of the pile because fungi, again, it doesn't really like the heat. It wants to be in a cooler area that's more in that blue outer layer, and it works its way in. So if you start seeing strips like this, I mean, get excited. That's your pile getting healthy. And these are the two side by side. This is fungi and this is actinobacteria, and this is what they look like under a microscope. So they're pretty similar across the board, but this is just one example of many visual observations you can make to improve your health of the compost pile. Okay, so when is it time to cure? When do I let my pile sit and let the fungi do its thing? Um, it depends. I'm sorry, I can't give you like a straight answer. Um, One thing is if it starts smelling, like earthy, there's a certain smell that literally produces serotonin in our brain. I mean, that's the connection we have with soil. So if you smell if you smell your compost pile and you get suddenly happy, that's when it's time to let it cure. But if your temperature starts getting around 100 for a small scale pile, maybe even cooler, the larger piles, I would let it cure when it got like 110, and it would kind of depend on capacity. But basically when your pile cools, it's time to let it sit for a while. And the color you're looking for is a dark, rich brown. You don't want jet black compost. That black gold saying, unfortunately, is a misnomer. We're really looking for a cocoa gold. Um, so you're looking for that color of humus, of humic acid, which is a very rich dark brown, and it kind of stands out when you see it. Like I had one pile that like finally you'd take the wood chips and they would just crumble, and it turned into this dark brown, and it was very exciting to see. When you see it, you'll notice. Um, and in the curing phase, this is when you might want to think about adding a little bit of fungal food. Again, it's going to be wood chips, it's going to be fall leaves. I say specifically fall leaves because everything has a carbon nitrogen ratio. Like I'm made up of carbon nitrogen. So even the carbon materials have nitrogen in them. But in the fall, they're packing up for winter, right? So they're sucking all their nutrients into the root system. So what's left over ground is super carbon heavy. In the spring, everything's pushing out of the ground. It's time for life. Everything's growing. So everything's going to be more nitrogen heavy in the springtime. So I would encourage you to use your fall materials in the curing process. I wouldn't add wood chips that are completely full of sap. Sap is a natural fungicide, right? You don't see fungi decomposing trees that are alive very often. The sap keeps them away. So you want to get dry wood chips that have gotten rid of all their sap. And this is like a progression I want to show you of Um, my leaf collection as my scale grew. First, it was community garden. They would drop leaf bags and we would debag them on site. And like, I mean, this is community right here. This is community compost. Um, and then the next phase, I would go to neighborhoods with a box truck and I would pick up, bagged leaves and I'd bring them back to the farm and I'd debag. And I mean, that was also a lot of fun. But then at a certain time, you got to get a truck, you got to skip all that plastic and go directly to the source. And this year at EcoCycle, we diverted 800 cubic yards of leaves kind of on a whim. It was like my first week on the job and it was pretty easy. Farmers want leaves. It's a great mulch. I can't say enough about how important fall leaves are for compost and soil. What is this? Sifting. Okay, so these are two examples of sifting, a large scale and a small scale. Um, I'm not necessarily a fan of sifting. I think it's important because you want to get that surface contact with your seed. You want something that looks really pretty like this. I mean, how beautiful is that? But if there's no wood in that, if there's no wood chips, there's less of a lunch that you're packing for your fungi. Like I want to boost the fungi in soil. So I want to have as much carbon in my soil as possible. I don't want to get in the way of growing vegetables, so I don't want to like be growing in mulch. But I really don't have a problem with some chunks in my compost. If you're growing in potted plants, if you're going in a super small scale, yeah, sift your compost. It's really nice to work with something that's more manageable. Okay, now we're going to talk a little bit about soil. We've mostly been focusing on bacteria and fungi. Um, and in soil, there are many, 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 many different characters, and they all need to play their part. So the bacteria is sort of like at the bottom of the food chain. The bacteria it's like the bunnies or the mice in an ecosystem. Everything pretty much eats it. Um, you have microarthropods, you have nematodes, you have protozoa, all these weird looking creatures. Um, so this is a nematode. Nematodes are microscopic worms. Um, and they almost all, I mean, a lot of them are hunting bacteria, and that's what this nematode is doing. Um, a lot of people are, well, not a lot of people, but I used to be afraid of nematodes because I would hear stories about root feeders, because there is a certain type of nematode that eats plant roots. But if you do your studies and if you understand the ecosystem, there are many different types of nematodes. And we look at the mouth part of the nematode to understand what it's eating. So this is a bacterial feeder. And a bacterial feeder kind of eats like a whale eats baleen in the ocean. It's like has like kind of like a vacuum in its mouth. And we look at its chest parts because it's kind of like a pump that kind of like siphons the bacteria into its mouth. Um, there are other nematodes. There's some with spears in their mouths. Those are the ones, a lot of them that eat the plant root because they have kind of like a straw and they penetrate through that cell wall of the plant and they suck out all the nutrients. They're another type that eat fungi and have that same spear. But then there's the probably my favorite type of nematode is a predatory nematode. And this is a nematode that eats other nematodes. It's about twice as big and has a tooth. So I'm just like explaining a couple characters, but really the relationship between the nematode and the bacteria is my point here. The bacteria, I mean, bacteria is one of the oldest, I think it is the oldest living organism on Earth. It's been surviving even though it's at the bottom of the food chain. How does it do that? Well, bacteria naturally produces like a glue substance. This serves a couple purposes. One, it protects itself from that nematode suction mouth, right? The nematode can't suck it out of its glue houses, so it's a preventative measure from being hunted. This glue is also uh, keeps the nematode from being washed away in a flood or a heavy rain. Um, this is the basis for soil structure. This is what happens when you put compost in soil. This is what the bacteria does. The fungi, as I said, it grows out kind of like in a web, and the fungi kind of lassos these bacterial houses together. and they clump them all up to get together, and that's where you form aggregates. This is soil stability. This is chunks of soil that are really, really good at absorbing and retaining water. So what happens if these chunks of soil get like really, really packed in and there's all this bacteria and it's breathing up all the oxygen? Well, this is a rotifer. And a rotifer has a telescopic mouth. It has like a motor. It has like two little propellers on its rear end, kind of like a motor. And it loves low oxygen conditions, just like that actinobacteria. And what the rotifer does is it's like the housekeeper of soil. It takes this aggregate and moves it over here. It takes this clump and moves it over here. It's eating bacteria, but its function in soil is aerating. So it adds more pore space, just like in a compost pile. And this is all of it happening together. This is the nematode hunting the bacteria. This is the rotifer eating the bacteria, and this is soil being built right in front of our face. I mean, it's pretty amazing to watch all this stuff happen. Look, it has a clump right there. I think that's in its tail, but it's still rearranging these soil particles. Now, this is the only part of the conversation where I'm going to talk about the non-living part of soil. This is parent material. These are the rocks and stones. They're still microscopic in many cases. And this is the non-alive part of soil. These are rocks that are broken off of like tectonic plates that are weathered off of bedstone or whatever. And these rocks come in different forms. I'm sure you've heard sand, silt, and clay. These particles, just to give you a scale, I mean, clay is 300 times, 30 times to 300 times, a lot smaller than sand. It's super, super small. It's the same size as a bacteria. It's hard to tell the difference. Here in Colorado, when I'm trying to assess bacteria, the clay is always in the way. That's what I've heard. So this, these different soil textures interact with water very differently. Um, So a sandy soil has a really hard time holding water. Water can come in, but it flows right through. And this is the problem that happens in a place like Florida, where it rains a lot. You'll have sandy soil near water. That's where water is flowing. It's kind of washing away all those clay particles. So how do I keep my water? You add organic matter. And in this context, organic matter means compost. So those little glue houses that the bacteria form kind of glom these sand particles together. They kind of stick them together and they make them much better at absorbing water. Clay soil. Clay is not a boulder, it's a platelet. And what happens when these platelets stack, it's kind of like if I had a stack of paper and I want to take from the middle, you'll probably get a couple that are kind of stuck together, they're kind of charged together. That's what happens in clay soil. So clay soil has a really hard time taking water in, but once water is in, it's hard to get it out. Like it's a problem. Your clay soil will become waterlogged, as many of you in Colorado, I'm sure know. So how do you solve this? The same thing, compost. Compost has the opposite effect on clay soil. It takes these particles, these clay platelets, and it kind of breaks them up. It flocculates. So you're making more pore space to allow your soil to absorb more water. Um, Now I'm going to talk about some small scale compost methods. I'm glad we have time for this, but these are different ways you can compost. I've been talking mostly about the turning method, but there are many, many, many ways to compost. I implore you to look on YouTube and discover some of these. In the note slides, I have links to YouTube playlists on each one of these topics. So I'm going to briefly cover them now, but if you want to know more, click on the links. This is a Johnson Sioux bioreactor. They have holes in the middle, and what happens is the heat from the compost actually sucks the air through and allows for more oxygen to go through. This is a longer system. You want to let these sit for like a year plus, but you don't have to turn it. And if you let it sit there long enough, it'll make a really high quality product. When you're making a static pile, it's super important to get the moisture and the mixture right at the beginning. Like this is your only chance. So if you're making a static pile with it, whether it's Johnson Sioux or some of the others we're going to talk about, just make sure that you get your moisture right. Make sure you get it at that squeezing, just a couple drops come out, about 50 to 60% moisture. And make sure you get that mixture right. Put in extra time mixing. The way I use Johnson Sioux bioreactors was kind of like a finishing process. I would turn my compost, it was pretty much there, and then I would form the Johnson Sioux and let it sit for like another year or another 6 months. This is an aerated static pile. The idea behind this is you're blowing oxygen through these PVC pipes through the bottom of your pile. So you can kind of skip turning because you're still getting the oxygen through the bottom of the pile. I'm still a fan of turning. I don't necessarily think, especially on a small scale, this is a set and forget system. If you get your moisture right, if you get your mixture right, you'll have a much better chance. But again, this was kind of like a curing bay for me. So I would make all my compost and I would fill it all into this bay and then I would turn the pump on. So at least it's getting some oxygen in the center and it's still getting that curing process. And this is what it looked like when it was getting filled up. As you can tell, this is starting to look like compost already. So I didn't necessarily trust this system to be a set and forget. And then this is a recent one that we've built at EcoCycle. Um, this one does a really great job of aerating. It has these vertical pipes coming up, but it is extremely hard to turn. So you always want to take those factors in. I'm using this bin now for something that I'm just going to leave it in there for a year plus. And then, feel free to experiment. I mean, this is an aerated static integrated with a Johnson Sioux. So it's blowing oxygen. It still has those air pipes. There's plenty of room for innovation in composting. And I take the step, take some exploration and experiment at home. Worms. I wish I had more time to talk about worms today. They can do my job faster than I can. You don't have to turn. It does get much harder at a larger scale, so I wouldn't necessarily recommend this. I would recommend starting with a Rubbermaid bin. But essentially, what you do with worms is you make a bed of leaves and you emulate what would happen on a forest floor. So that these are worms that want to live on a forest floor and they want to eat the fruits or the vegetative waste that falls off of a tree. So you make your leaf bed and then you put food scraps on the top, and they churn through that stuff very quickly. And then this is a large scale worm bin that I had at the farm. And again, it's the same concept. Underneath, it's just a big bed of leaves, and worms really like manure. One of the downfalls of worms is they won't eat weed seeds. A worm pile wants to be 65 to 70 degrees, 65, 75 degrees. They're very temperature sensitive. They're like Californians. So you want to make sure that you try to keep your weed seeds out of your worm bins. So in an agricultural setting, all my manure, or the majority of my manure, would go to my worm bed. Compost tea, compost extract. I could go on for hours and hours and hours about this, but this is a really great method of taking a little bit of compost and putting it and transporting it much easier. You're getting all the microbes off the compost into the liquid, and then you're transporting that liquid and applying it on the ground. Um, this can serve many, many beneficial purposes. I mean, this can be a foliage spray. You're spraying the leaves to protect, you're building a bacterial film that will protect from external diseases. It can be a soil drench that works the microbes up the plant as the plant grows. It could fix a compost pile. These days, I'm using compost extract, which is like compost tea, um, to rejuvenate piles. If I see a pile on a farm that's not going so well, I drench it with compost tea or compost extract. And that is a great way to solve that stinky problem, to get the microbes that are beneficial into that pile and let them do their thing. Hugelkulture. If you have a bunch of logs laying around, this is a way you can grow right into your compost. It's not necessarily compost, it's a lot of wood. You can put a lot of compost in there. You build up a mound. Here, let me see this. Okay, so you build up a mound and you can grow right into that mound. Um, and it breaks down over about 7 years. I recommend that you click on the link. You'll see some fantastic mushrooms. I mean, I kind of even got this pile wrong because there were so many mushrooms, they were disturbing the plants. But especially in that initial phase, you'll see the fungal decomposition happening right in front of your eyes. I mean, look at these giant balls of mushrooms. Um, but I think this is the best way to just make your soil super, super carbon rich, boost that fungal activity, and you can also grow into it. Okay, so now coming to a close, I want to talk about soil and how important it is to our earth. I mean, this is what's happening right now is our planet cannot breathe. We're choking out our planet through our emissions. And if we were to fix all of our soil today, we could reverse climate change in a couple years. So what I love about composting is it's something proactive I can do in our situation right now. I mean, I can drive big machines and I can do more and more and more of it. And it's that my footprint is a good thing. I mean, I think about climate change and there's so much in reduction that I feel bad about the things I do, but I don't feel bad about composting because composting is a world saver. This is something we can do to reverse climate change, not just preserve where we are. Um, and I actually, before I went and started farming, I wanted to be a park ranger. And I'm happier doing what I do now because this is proactive measures. And I think where we are now is where we're beyond preserving. We need to preserve what we have, but we also need to regenerate. We need to regenerate our soils and regenerate the plants that naturally live on our planet in our natural areas. So I think we got about 10 minutes for questions. Thank you all so much for listening.
Yeah, and thank you so much, Rutger. This was a fantastic presentation, very informative. And luckily, we've got plenty of time left over for questions. One, I just wanted to start out with, I was wondering if you could tell us a little bit more about the microbe brew compost tea that you guys sell over at EcoCycle.
Yeah, happily. Yeah, so this is actually we're doing an extract this year, so it's a soil drench. Um, One of the things I'm doing, and if you get into making compost tea or extract, is I'm adding mycorrhizal fungi to it. This is a fungi that needs a plant root to live. So it's one of the very rare instances where we can't produce that microbe in compost. So, we're taking the compost that's taken all these steps that I'm talking about. It's like, by next year, it'll be over a year's worth of production. But then we're also adding the microbes that need to live in symbiosis with the plant. And adding that mycorrhizal fungi, I've seen tremendous results.
Nice. And folks can buy this compost tea on site at EcoCycle, right?
Yeah, we sell it at the charm window. If you have hard to recycle material, or just give us a call, we'll give you some more information on it.
Perfect.
Thanks.
Thank you for that. A couple questions we didn't get to initially. We had a lot of folks asking about pine needles and grass clippings and whether or not those are a good additive. If so, would those be considered a green or a brown?
Um, grass clippings, if you're mowing your lawn and you have grass clippings on your lawn, it's better to suit your soil to just let it break down. Not if you have like an inch layer, that's not necessarily a good thing. I would worry about grass clippings matting up and creating one of those like anaerobic pockets. If you mix it up well enough, it'll do just fine. Um, Pine needles, they take a while to break down. They have like a wax coating on them. Green or brown, that's a good question. I'd say it's like, I mean, it's more of a brown than a green, but it's not Um, yeah, it's like closer to the middle, kind of on the brown end. Everything's on a spectrum here. Um, I used to use pine needles. They would come in the leaf loads and they'd break down in time. But in a smaller pile, I'd be cautious.
All right, thank you. We've had a couple messages from folks who have excess compost, either they bought too much or they're able to produce uh, too much in their own backyard. How long does compost last? Is it something that they can store it in a specific way and use it next season, or is it kind of one and done?
Yeah, I mean, if you have compost that's sitting there, and you say, well, maybe I'm not going to use this for 6 months, you can put leaves in it, and add some food, kind of buy some time. It's still something you want to like lightly manage. You want to make sure it's keeping its moisture, and I would recommend keeping it covered. Man, I don't think I even mentioned you got to make sure your piles are covered. It's super important to keep that moisture in here in Colorado. And the same is true for a finished pile. If it loses its moisture, it will die. But if it doesn't even die. Like it'll come back to life if you hydrate it. It just goes dormant. So keep it wet, cover it. Maybe think about making aerating it with some leaves or wood chips.
Perfect. I've got another question. The question is, what do you think about mulching the leaves to store them? I think maybe this is referring to like if we have, a lot of leaves in the fall, how would we store those, so they can be used in the spring?
Yeah, yeah, like mulching as in shredding, that's a great idea. Yeah. That was a huge problem. Our leaves would blow away and I didn't really have a way to shred them up. Um, Another little trick is I would mix like maybe a 3-to-1 ratio of leaves to wood chips. So you'd have just a couple some wood chips to kind of weigh it down. Again, maybe keep your pile covered. But if you have the capacity, chopping it up is a great solution.
All right. Another question we got, someone mentions that they have lots and lots, hundreds of worms in their compost pile. Is that a problem? Is that good? If it is a problem, how do we go about managing that?
Um, Man, if I were in that case, I would probably like let my pile sit and no longer turn it, and it would just end up being a worm pile. If you reach your hand in and you have 5 or 6 worms in there, that's enough to just take over a pile. That happened to some of my big piles at Chatfield, and it was great. It's a great thing. There's not, there are worms that people are concerned about, but I think they're mostly in California. The little red ones are the ones you like. They're red wigglers. They like it living at the surface and they decompose things. The big gray ones are your earthworms. Those are also a good thing. They're night crawlers. So worms are a good thing.
Awesome. Another person asked, given the challenges with like small scale composting, like from an apartment or a small home, do you think it's worth, going about and doing that as much as you can yourself, or is it probably easier to just join, like a local composting group and get your compost that way?
Um, I think they're equally valid. I as long as you're keeping it out of the landfill and someone's turning it into compost, that's the end goal. And if you have, if you have the budget, let someone else make the compost, and there are some really great bucket haulers doing great work. So I think that's a great use of your organics.
Okay, awesome. Let's see. I think that's kind of it for the majority of our kind of, more general questions. So since we've got a bit of time, I was going to ask some more specific ones if that's okay with you.
Okay.
If you don't know the answer, let me know. That's totally fine. First, we have someone asking about transitioning from like a countertop composter to a compost pile outside. Do you have any like recommendations for that?
Um, well, those countertop composters are also a hot topic. Most of the time, they're a dehydrator. So they'll dry everything out. It's kind of like a bread maker. I have one at home because I just want to know what they're about. But they're not really making compost. They're mostly just dehydrating the material. If you want to do it at home, like what I was doing for a while, and it was very successful, was I would put my organics in the composter. It would make this something that looks like compost. It has the texture and everything. And then I would put that in a worm bin. And the worms love it. I mean, they would just go right through it. So I think it works really well in tandem with the worm bin. And that's what I'm recommending, even for like the super large scale. I'm like, okay, well, now you got to start a worm farm.
We've got a couple folks here who are concerned about attracting unwanted visitors like rats, mice, bears, raccoons, possums. Do you have any experience with that or any recommendations for maybe deterring, uh, different pests?
Um, yeah, I mean that is a concern in an urban environment. Keeping it covered helps. If you're making a bay system, you can line it with like hardware cloth, like a half-inch grade or a quarter-inch grade. That'll keep them out. And then, managing your compost pile well helps tremendously. So, if you have exposed food scraps on the outside of the pile, that's going to attract pests. Whereas if it's in the middle in that center core and decomposing, it's much less likely. So, take the measure you need to, but like covering it and walling it in with hardware cloth is helpful.
Okay, fantastic. We got about 2 minutes left, and I think one more question that maybe you can answer. You'd mentioned the mycorrhizal fungi that you use in your compost brew. This person's just asking in what form? I guess maybe is that something that folks should be adding to their personal gardens? If so, like where could they find something like that?
It's in the form of a spore. And what I like about it is, if it's going to survive in the soil, it's going to, the spore is going to germinate, and if it's not, it's not. So it's not like a bunch of bad stuff is going to start happening. I don't want to give like product recommendations, but I believe it was trichoderma is the one you want to stay away from. Um, that's a that's a microbe that's used, I think, as a preservative. I'm like right at the depth of my knowledge here, but when I was shopping around, I was looking for one that did not have trichoderma and that was I don't know what you call it when you for hydroponics, like mineralized or atomized. It was atomized and it didn't have trichoderma.
Okay, awesome. One more question, if you don't mind.
Sure.
This just came through. We talked about covering a compost pile, and so we're wondering, what's the best material to use? Is that some kind of substrate? Do you just use like a tarp or a cloth?
Great question. Really glad you brought it up. In that first slide when I was showing you how I started, I used to cover my piles with straw, and that worked great. Um, if you don't have a tarp, just find something. If you have a tarp, that's great. If you have something that's breathable, that's even better. So the most common thing you'll have around is landscape fabric. It's like woven plastic. So it'll allow a little bit of oxygen to get through that material, but it'll keep the moisture in. If you have something that's completely impermeable, I used to leave like a foot of space between the bottom of the pile and where the tarp started, and that would kind of allow oxygen to blow in from the side. Um, Everything's a give and take. So, like just what I said about pest management, you would be giving and taking with adding that gap where a pest could come through. So, do your best. Like, you're not, if you need to keep the pests out, just cover it. Just cover it all, seal it. But ideally, you'd want to poke some holes in that tarp and you want to let some oxygen flow.
Okay, fantastic. Thank you so much. Well, we're at 8 o'clock, so we're just going to be wrapping up. Rutger, thank you so much for this presentation. I learned a lot, so many things I never knew, and I hope everyone who joined us today feels empowered to start their own compost pile.